So now we're going to look at how to measure delta H. So remember, this is the energy in the form of heat to make and break bonds. Let me show you this picture. You measure it in what's called a coffee cup calorimeter. And you literally, if you see this picture here, it's 2 coffee cups on top of each other, have something to seal it. Here's a thermometer you put at the top. And so you can measure the heat, because you have to measure the temperature difference. And this is a glass stirrer, so you can stir the reaction. Okay? Remember we said delta H of the reaction equals Q of the reaction. So delta H, this is done at constant pressure, okay? Because when we're in a coffee cup, we're not changing the pressure. It's just atmospheric pressure. We don't put pressure into it. It just remains the same, okay? So delta H of the reaction will equal to Q of the reaction. And just like we did a calorimetry problem before, you're going to get Q of the calorimeter, and that'll equal to negative Q of the reaction. Okay? Now remember, what is Q? Q is MC delta T. M is mass in grams. C is going to be the calorimeter specific heat, so how much energy it'll take to change that temperature. So we'll say it's a constant. And delta T is just T final minus T initial, so it's your temperature change. And so once you solve this to get that, you would get Q of the calorimeter, change the sign to get Q of the reaction, which will give you delta H. Okay, so let's look at this problem here. Okay, and how do you know it's a calorimeter problem? Because it'll say calorimeter in there. Let me see. Here's a specific here. Hey, wait, somewhere, I don't really see it in here. Oh, here it goes. A coffee cup calorimeter, okay? It'll say coffee cup calorimeter, versus the other one will say bomb calorimeter, okay? So here's the equation we're looking at. So let's read this carefully. In an experiment to determine the enthalpy change, so delta H, for this reaction, 0.158 grams of metal, or magnesium, is combined with enough hydrochloric acid to make a 100 milliliter solution in a coffee cup calorimeter. So let's put what we have here. We have our magnesium equals to 0.158 grams, and we know our hydrochloric acid was 100 milliliters. So that's how much reactants we have in there. That's a 100 milliliter solution. Sorry, that's not hydrochloric acid. This is of the solution. Okay, the HCl, the hydrochloric acid, is sufficiently concentrated so the magnesium completely reacts. Okay, the temperature of the solution rises from 25.6 to 32.8. So for our temperature final, I'm going to put right here, we have 32.8 minus our initial was 25.6. If I go ahead and subtract those out, I should get 7.2. So my delta T is 7.2, and that's in degrees Celsius. Okay. The density, 1 gram per milliliter, is the density of the solution. So density of the solution is 1 gram per 1 milliliter. Okay. And then it says C for the solution is 4.18 joules grams degrees Celsius. So C up here, this C right here, I'm going to put is 4.18, and that's going to be joules grams Celsius. Okay, So let's look what I have here. I have Q, that's what I'm trying to find. I don't know what M is, let's leave that blank right now, but I do know C is 4.18. Remember, this is in joules, grams, Celsius. I know my delta T is 7.2. Okay, now I need to figure out M here. Let's look what I have. There's a hint, or a few hints. I have a mass for magnesium, but I also have sort of like a mass, if you want, for the solution. So which one do I use? Now let's look at C. Do you see it? C was given, if I come back to the problem, C is specific heat for the solution. Okay, since that's specific for the solution, you have to have the mass of the solution. So this is actually what I use here. I don't use the magnesium mass, I use the solution mass. And you'll always do that. You'll always be the solution mass, okay? But I don't want it in milliliters, I want it in grams. So do you see here, I have 100 milliliters, and it says the density, I have 1 milliliter per 1 gram, because this is the density of the solution. So I had 100 times 1 divided by 1, so this is actually 100 grams solution. And that will actually equal to my M. So my M is 100 grams. So let's see, grams will cancel, that was in degrees Celsius. Degrees Celsius cancels, that'll leave me in joules. So Q, I multiply this out, 100 times 4.18 times 7.2. I will get, let's see, 3,000, where is it? 3,009.6 joules. But my final, it said my final units, let me put this in another color. I want, my ultimate thing is kilojoules per mole. Okay? So I don't want joules, I want kilojoules for 1. Okay, so let's first convert this to kilojoules. This is just a quick unit conversion. So there are 1,000 joules per 1 kilojoule. So that means you have approximately 3 kilojoules. Okay, so now it's in kilojoules, but I want it per mole. And so that's where the mass of magnesium comes in, because it wants it in moles of magnesium. Okay, so I have 0.158 grams of magnesium. Convert this to moles, where anytime you go from grams to moles, you need the molecular weight. Well, on the periodic table, magnesium weighs 24.3 grams per 1 mole. So if I divide that out so I can get moles, I get 0.0065 moles magnesium. And I'm almost there, okay? So I have 3 kilojoules, but I want it kilojoule per mole. So let me change my color again. Let me go to a blue. Alright, so I have 3 kilojoules, and I have 0.0065 moles. So if I divide those numbers out, I will get 461.5, we'll say, kilojoules per mole. Okay, so now we have the right units and everything. But remember, this was Q of the calorimeter we found right here. So let's look up here. Q of the calorimeter is negative Q of the reaction. So I just need to change the sign. So for Q of the reaction, all I have to do is just change that sign right there. So it's a negative. And you see negative, so Q of reaction is delta H. So this is your delta H. That's your final answer there. Purple, I guess. So this is our final answer. Remember to always change your sign at the end because you're looking at Q of the reaction, not Q of the calorimeter. Okay, so let's think of what we did here. All we did was MC delta T. We found the change of temperature given. It gave us C of the calorimeter. That's a constant. It has to give us that. The hardest part was this mass, trying to figure out what mass. Well, in a calorimeter problem, you're always using the mass of the solution, okay? So we had to convert the milliliters of solution to mass of solution, okay, to plug that in there. But once we have that, we just plug it into MC delta T, get it in the correct units, and change the sign, okay? So this is how you can easily measure Q of the reaction. So C is something you can look in the table. Delta T, you literally just measure with a thermometer, the change in temperature. Mass, so once you mix everything together, the whole solution, what does it weigh? And that's where you get M in there. So if you have MC delta T, you can get Q, change the sign, and you get Q of the reaction, which is delta H. So that's how we usually measure it. So it's not too bad. It's going to take a little practice there. The big thing is remember what units you want to put it in. And remember, you always want mass in the solution.